Good afternoon, I'm Mr. Ish. Thank you for joining me for this video where we're doing an algorithm for determining a maximum from a list or an array of numbers. That list or array or grouping of numbers could be millions or thousands, and you would have to determine the maximum from all of that. How would you develop an algorithm for doing something like that? Something which is quick and efficient. Of course, this is not the typical high school topic here, but it would come under discrete mathematics or coding or computer science, all of which are math related. The procedure for developing an algorithm will start with the basic development of a rule. That rule would be what are your possible input values that your computer program can accept. You would have to set this from the start, would be your domain of inputs. And it doesn't have to be anything too fancy for the purposes of this video, but for reality purposes, this domain of inputs could be anything from minus a million to a million. Who knows what your program can accept. But for the purposes of this video, we'll keep it to 0 to 10 so we can keep everything to the point. Now you would actually develop your algorithm, and the first thing you want to do is determine what your maximum is. You want to set your maximum, your standard, to the lowest number of possible accepted values, which would be 0. Then all the comparisons will be made using that. As each step goes by, that maximum may or may not change. Now will come actually the loop part where you do your comparisons. The comparisons part will be the most fundamentally important part of this entire algorithm. It could be made of many steps, but these would be an example of what your steps would be. You would do a comparison of your test number, and we'll just call that test number. We'll have a list of numbers. What are those numbers being tested? We'll symbolize that as this. What are they testing against? Your maximum number. If your number is larger than the maximum number, then you have to set a new maximum, and your maximum will become equal to that new number. And this maximum can change as your program goes by. If, however, your number is being tested against a maximum number, but the number is less than maximum, then your maximum will not change and it can stay the same. And we'll just say DNC, it does not change. It stays as is. If when your number is being tested with the maximum, it happens to be equal to the maximum, the number which is being tested from that list of numbers is equal, your maximum of course does not change, it stays as is. The procedure can repeat as many times as needed until all the test numbers or the numbers in your listing or your array are finished. Then at the very end we'll develop the output, and the output will just demonstrate what the maximum was, and the computer program would end. This right here would be an algorithm for determining the max. How can we show that this algorithm is good? Imagine you have a list of numbers which are this: 1, 0, 3, 6, 4, 6, and 9. You have 1, 2, 3, 4, 5, 6, 7 numbers, therefore everything will loop through 7 times. This loop right here will go through 7 times. Obviously at the very beginning you're setting your maximum, which is 0. Your max equals 0. That's being determined by the program. It is being set because our program is only looking here from 0 to 10. Now we come up to the first step, and the number will compare with the maximum. Our number is 1 and it's comparing against 0. Is 1 larger than 0? It's true, it is larger than 0. So now your maximum will become the new number which is tested. It will become 1. You see how the maximum started at 0, but by means of the first loop and the comparison with a larger number, maximum has changed. Now we're at 0. We'll compare 0 with our max. You see our test number and then the max. Is the test number 0 larger than your maximum, which is now 1? No, it isn't. It's false. So your maximum will not change. It's kind of, you're looking at this. It's less than that. It will not change. So your maximum will stay as 1. Now we're looking here at this next number 3. The 3 test number is being compared with your existing max. Is 3 larger than that existing max? It's true, it is larger, so your maximum will change now to a 3. Now we're at 6. The 6 test number will compare with the existing maximum, which is 3. Is 6 larger than 3? It's true, it is larger. Your maximum will have to change now to 6. Now we're at 4. Here we're doing a comparison between your test number and the existing max, which is now 6. Is 4 larger than 6? It isn't. It's false. You're looking at something like this. Therefore, the maximum should not change. It will remain as 6. Now we're here at 6. Now we're comparing your test number 6 with your existing max number of 6. Is 6 larger than 6? It's false. It isn't. But 6 is equal to 6. Therefore, your maximum should not change. It will remain as 6. Now we're at the very last number of your array or your listing. And it'll do that, and then the program will terminate and it will determine what the output is. Your test number 9 is being compared against 6. Is 9 larger than 6? It sure is. It's a true. Therefore, your maximum will convert or will change into the new maximum, which is 9. And finally, your computer program or your algorithm will end. It will demonstrate and place the output for everyone to see, and it would be a 9. And the program would take a matter of a second or less for it to operate, because computers are that fast. Imagine you had a list of millions or billions of numbers. You could have negatives in there, you could have positives. Then a program or algorithm like this comes in very handy, because it can very quickly sort the maximum for you, and it can also group all the numbers. But we're not showing you that algorithm here. We're only showing you algorithm for determining the max, and this is there for you, and the example is over here. You see, you have 1 2 3 4 5 6 7 numbers. You have 7 steps in your loop, and then the termination step over here, and the output is demonstrated. And that's it for this video. Thank you for watching.